Hi guys, welcome to chapter 19. We're going to continue talking about things that take place in the atmosphere, specifically weather. Okay, so section A is on weather. We talked about this before, but weather is the specific conditions that are occurring in the atmosphere, like where you are, when you are. Climate is something we use more to talk about patterns and predictions, but weather is like when you go outside, it's a description of what's going on in the atmosphere around you. Okay, and we look at several different measurements, several different variables when we describe weather. Okay, so temperature obviously is a big one, but we also look at the air pressure, and that's one that like scientists and weather forecasters really know how to read. That's not one that we talk about on a day-to-day basis, but it really has a huge impact on the type of weather that we'll have. We'll talk about that a little bit more later, but the air pressure, high or low kind of thing. Wind, how fast it's moving, if there's any precipitation, and humidity. Okay, now I'm going to talk about humidity a little bit more, and we're going to talk about precipitation a little bit more. But remember, precipitation is just basically water that falls to the earth, and it could be frozen water, it could be liquid water. So we've got rain, we've got hail, we've got sleet, we've got snow, so that's all types of precipitation. Meteorology is the study of the atmosphere, and so therefore the study of weather would be part of that because it takes place in the atmosphere. And then a meteorologist would be the name of the person who is collecting that data, who's studying it. A meteorologist is like the technical term for an actual weather person. So the people on the news, they might just be a weather reporter. They might just be conveying information, but sometimes you'll actually have a meteorologist on the news. And they are the ones collecting the data, and they're actually predicting the weather based on that data. Okay. All right, so we measure all these things, all these variables we talked about, we have to measure those. So we have lots of instruments to talk about. This guy right here, if you look on the roof of the 300 building, we actually have a weather station here at Christ Brea, and it measures all of these things that we're talking about. Okay, if you go to our website, there's actually a link to ambient weather, and it's all the information that's coming from those instruments on our roof. Okay, so one thing it measures is the temperature with the use of a thermometer. Okay, it has a barometer, which measures the air pressure. It has an anemometer. That's these little guys, and they spin around, and that measures the wind speed. So the faster the wind is blowing, the faster those will turn, and the higher the wind speed will be relayed. A rain gauge is something that's used to measure rain, the amount of rain. I don't know for a fact if that is the rain gauge on there. Sometimes you can see a rain gauge, and it just looks like a graduated cylinder. It's just like this tube that has markers on it, and it literally collects rain, and you read how deep that water is, and that's how much rain was received. Okay. There's also something called a hygrometer, and that is the instrument that measures humidity. And humidity is kind of a big deal because it can make a temperature feel even worse. If it's high temperature and high humidity, that's when it feels really muggy outside. Same thing with wind. We get something called the wind chill, and it's not something that affects us so much here. Definitely something, in the Midwest and East Coast, but sometimes the temperature from the sun is one reading, but then if the wind is blowing, it actually makes it feel colder, and that's known as the wind chill. Okay. All right, so back to humidity. Humidity is the amount of water vapor that's in the air. So remember, water vapor is the gas form of water. And however much of that there is in the atmosphere, that's known as humidity. Okay, but we compare it. We really use this term called relative humidity more than just regular humidity. So what relative humidity is it's a ratio of the water vapor that's in the air compared to how much it can actually hold. So the atmosphere, depending on the temperature, depending on some other variables, can only hold a certain amount of water vapor. And that would be known as, 100%. Okay. So if the relative humidity is 100%, that means the air is saturated, and that means that water vapor is actually going to start condensing back into liquid water. And that might fall as rain, or it might be really just like kind of foggy or dewy or just kind of wet. Okay. The lower the percentage, tells you how far away from being saturated it is. So the lower the humidity percentage, that relative humidity, tells you that there's that much more room in the atmosphere to hold more water vapor. Okay. Now, the reason this matters is because our bodies cool themselves off by sweating. And in order for that to work, the sweat needs to actually evaporate. That liquid sweat needs to turn into water vapor. But if the air is close to being saturated, it doesn't want any more water vapor. And so the sweat will not evaporate and it will not cool us off. And so that's why when it's really high humidity outside, it just kind of feels muggy and it feels hotter than it usually is. And it's just like, ugh, it's awful. Definitely something that happens in the South and on the East Coast more than here, but we get plenty of humid days here also. Along with that is something known as the dew point. And so each day, the dew point is the temperature at which the air would be saturated with water vapor. Okay, and it's usually lower than the actual temperature. The higher temperature the dew point is, means the higher temperature the air is going to be, and it's just going to feel muggier. Okay, but typically the dew point is somewhat on the chilly side, and so if the air cools down to that dew point, then the water will condense. That's why we get dew in the mornings. That's why when you go outside, sometimes the grass is wet. That's because the air actually cooled down below that dew point, and so the relative humidity went up. So as the air cools, the maximum amount of humidity, the maximum amount of water vapor the air can hold actually decreases, and so it's easier to be considered saturated. And so then it starts condensing, and that's why it's wet in the morning sometimes. That's it. See you later.